Other than the moon and the Earth, the only other planetary body we humans are conversant with is our sun. With the sun shining in the sky for most of the hours when we tend to be awake, it shouldn't come as a surprise for most people to tell you they already know all there is to know about our sun. But this cannot be further from the truth. Although we have become familiar with our closest star, there is still so much to be unraveled about it. When was it formed? How was it formed? Could its death bring about the end of our solar system? Keep watching till the end to discover some of the sun's best-kept secrets. Compared to our little slice of life, the sun's diameter is 1,378,657 kilometers larger than that of Earth's. In fact, the sun's volume is so large that approximately 1.3 million Earths could fit inside of it. When it comes to the mass of the entire solar system, the sun makes up a whopping 99.8% of it, leaving a measly 0.2% for the rest of the formations to fill in. And most of that final 0.2% comes from Jupiter. So, the mass of the Earth is a fraction of the mass of the solar system. Really, we barely exist. If you could take apart the sun and pile up its different elements, you'd find that 74% of its mass comes from hydrogen, with 24% helium. The remaining 2% includes trace amounts of iron, nickel, oxygen, and all the other elements we have in the solar system. In other words, the solar system is mostly made up of hydrogen. In space, everything has a classification. For instance, Earth is classified as a terrestrial planet, Jupiter as a gas giant, and Mercury as an inferior planet. Stars are no different. And when it comes to the sun, you're looking at a full spectral class of G2V. The G designates it as a main sequence dwarf star that converts hydrogen to helium via nuclear fusion at its core. G-type stars are known to fuse hydrogen for roughly 10 billion years, at the end of which it will expand to a red giant. If anyone's left on Earth at the time that happens, they will be completely engulfed by the inferno. We know of some amazingly large and bright stars like Eta Carina and Betelgeuse, but they're incredibly far away. Our own sun is a relatively bright star. If you could take the 50 closest stars within 17 light years of the Earth, the sun would be the fourth brightest star in absolute terms. At a speed of 299,792 kilometers per second, you could say that light travels pretty fast. What does that mean for the relationship between Earth and the sun, or the sun and any other planet for that matter? Light emitted from the sun takes approximately 8.3 minutes to travel the 1 astronomical unit. But there's a peculiar fact about the light we're getting after those 8.3 minutes. It's estimated to be anywhere from 100,000 to 50 million years old by the time it reaches Earth. The light is produced within the sun's core, starting as gamma rays that collide with matter until it reaches the surface. There's no direct measurement to how long that process takes, but it is known to be far more than a mere 8.3 minutes. The sun looks like a burning ball of fire, but it actually has an internal structure. The visible surface we can see is called the photosphere and heats up to a temperature of about 6,000 degrees Kelvin. Beneath that is the convective zone, where heat moves slowly from the inner sun to the surface and cooled material falls back down in columns. This region starts at 70% of the radius of the sun. Beneath the convection zone is the radiative zone. In this zone, heat can only travel through radiation. The core of the sun extends from the center of the sun to a distance of 0.2 solar radii. This is where temperatures reach 13.6 million degrees Kelvin and molecules of hydrogen are fused into helium. Unlike the planets, the sun is a great big sphere of hydrogen gas. Because of this, different parts of the sun rotate at different speeds. You can see how fast the surface is rotating by tracking the movement of sunspots across the surface. Regions at the equator take 25 days to complete one rotation, while features at the poles can take 36 days. And the inside of the sun seems to take about 27 days. The surface of the sun reaches temperatures of 6,000 Kelvin, but this is actually much less than the sun's atmosphere. Above the surface of the sun is a region of the atmosphere called the chromosphere, where temperatures can reach 100,000 K. But that's nothing. There's an even more distant region called the corona, which extends to a volume even larger than the sun itself. Temperatures in the corona can reach 1 million K. Unlike most of the planets in our solar system, the Sun's name is not derived from some Roman god. The word sun is believed to stem from the Old English spelling of sun, S-U-N-N-E. It wasn't always known as the sun, though. Ancient Greece dubbed the flaming orb Helios, the son of the Titans Hyperion and Thea. In ancient Rome, the sun was known as Sol, Latin for sun, and was attributed to the deity Sol and the less popular Sol Indiges. For ancient Egyptians, the sun took form as the god Ra, who was later merged with Horus to create Ra-Horakhti, or the god of the sky, earth, and the underworld. A satellite is described as an object that orbits around another object. You likely know our moon to be a satellite of Earth and Phobos to be a satellite of Mars, but have you considered the satellites of the sun? It may never have crossed your mind, but you are traveling on one of the sun's many satellites. Including Earth, the sun is also orbited by our neighboring planets, Pluto included, the dwarf planet, Ceres, and Halley's Comet. Accompanying this group is also a considerable amount of asteroids, an estimated 750,000 to be exact, orbiting around the Sun in a band found between the orbits of Jupiter and Mars. Many things have their own magnetic field, our planet included, but few are as powerful and instrumental as the magnetism of the Sun. Aside from creating beautiful solar flares for space programs to admire from afar, the Sun's magnetic field is believed to directly affect weather across the solar system. Here on Earth, there has been a recorded correlation between the surface pressure of the atmosphere and changes within the Sun's magnetic fields. When the Sun's magnetic field reverses, which it does every 11 years, there is believed to be a ripple effect through the solar system, with changes in cosmic rays and space weather occurring, potentially causing solar storms and a change in the Earth's climate. All good things must come to an end. As we've touched, the lifespan of the Sun is no different, and it too will eventually die. And with it, all life on Earth will cease. During its lifetime, the Sun burns through hydrogen, fusing it into helium. Eventually, all of the hydrogen will dissipate, leaving nothing but helium to try and power the Sun, which it is unable to do. The helium-based core will eventually start collapsing on itself, creating more pressure to heat and increase the size of the Sun until it is a red giant. When the process is complete, astronomers like Klaus Peter Schroeder and Robert Cannon Smith believe the surface layers of the Sun will reach out over 170 million kilometers, absorbing Mercury, Venus, and our beautiful blue planet. At approximately 4.5 billion years old, based on the 10 billion year lifespan we mentioned in its classification, the Sun should have another 5.5 billion years left, after which it will slough off its outer layers and then shrink back down to a relatively tiny white dwarf.